Okay, for this question, we have F, which stands for the force. And this right here is mu. It's like MMU. And it's actually a Greek letter. It stands for the friction coefficient. And the W is the weight of the object. And the theta is the angle. And this is the situation that you have the object right here. And you have a rope. And then just, drag it. And then how much force that you need and all that stuff. Anyway, our goal is to find out the theta value so we can actually have the smallest force, right? So you can imagine the theta has to be in between of what? 0 to 90 degrees, right? Anyway, we have to get our derivative, of course. So let's do the following though. Because this, and that, they are all constants, right? The friction coefficient and also the weight is also, they are just the constants. So let me just go ahead and write it as mu times W. And then here we have the mu sine theta plus cosine theta raised to a -1. It's easier to do the derivative this way. So here we go. F prime of theta. Right here, we can just go ahead and bring the power to the front, -1, and then do the chain rule right here inside, right? So when we do that, we get negative mu times W, and then we have the inside states, which is the mu times sine theta plus cosine theta raised to a -1 power, -2 power. And then we multiply by the derivative inside because of the chain rule. Derivative of mu times sine theta is going to be mu times cosine theta. I don't know why whenever I say mu, I just feel happy. Anyway, derivative of cosine theta is going to be negative sine theta, like this. Okay? Well, before I set this equal to 0, let me just clean this up a little bit. This and that will be on the top, right? So here we have negative mu. Yeah, I don't know how to write mu. It's just, I don't know. I did this in physics a long time ago, but anyway. Times mu times sine theta, sorry, cosine theta. Man, this is what happens if I laugh too much and make mistakes. Anyway, and then minus sine theta, right? All over this guy, which is mu times sine theta plus cosine theta raised to the +2 power, like this. Now, of course, we just have to set this to be 0 to find our critical number. Well, this is just a constant right here, and then this is the only variable part. So the critical number is when we have mu times cosine theta minus sine theta equals 0, right? The bottom, we don't worry about that. Anyway, let's go ahead and bring this to the other side. So we have mu times cosine theta equals positive sine theta. And in fact, I will divide the cosine theta on both sides because I want to combine it. And in fact, we can use tangent. That will help us out. You'll see this right here. Let me write it down first, which is tangent theta. That will be mu, isn't it? And then I want to get the theta by itself. So in this case, we are going to apply the inverse tangent on both sides, like this, right? So you see that our critical number is when theta equals inverse tangent of the friction coefficient, namely mu. And right here, you should technically do a number line, the derivative test real quick, right? So you have the theta value, and then you have the f prime, and then this is the value inverse tangent of mu, like this. And this is slightly kind of bizarre because you don't know what mu is, and all this is in terms of variables, right? So what you can do is you pick a slightly more extreme value, such as maybe when theta is equal to 0, and see what we get. When theta is equal to 0, this is negative. This is going to be just mu, right? And when theta is 0, this is 0. So it's going to be positive for sure, right? Because mu is positive. And the bottom is always positive. So in fact, we actually get negative right here. And then if you pick mu to be, let's say, again, we cannot have the, we cannot, sorry, if we pick theta to be pi over 2, we cannot actually have pi over 2, but whatever. If you do that, you will get this is 0, and this is going to be -1. So we have negative in here. Negative times negative divided by positive. All in all, we get positive. Anyway, that will show us that this right here is actually indeed a minimum. So the angle that we're looking for is inverse tangent of the friction coefficient mu, right? So that's it. Some physics right here.